My dear students, in our previous video, we have started the topic discrete mathematics, and we have defined the various concepts in discrete mathematics, namely binary operation, algebraic structure, and finally closure property. These three concepts we have seen in the previous video. I once again recall those concepts now. A non-empty set yes and operation star a non-empty set yes and an operation star and an operation star, a non-empty set yes and an operation star. This operation star is said to be binary on the set yes, means for any two ordered pair, or any two elements in the set yes, after operating this operator, the resulting element is also in the set yes. That is, for every a comma b ordered pair in the set S cross S, then A star B is also belongs to the set S. This operator operating with the elements A and B is again an element in S. If it is so, then the star is a binary operation on the set S. Then we can say star binary operation star. The operation star is a binary. It's a binary operation on S. This is we have seen. Yes, operation is said to be binary or not on the set, given set. Depends upon the elements of the set. If the elements of the set are satisfying with this operator and the resulting element is again in the given set, then the operation is said to be binary operation. And that binary operation and that set yes, the set yes and the binary operation in that set star is called an algebraic structure. Algebraic structure. The binary operation, algebraic structure. We have seen in the previous video. See, in an non-empty set yes, together with the binary operation constitute an algebraic structure. And if this operation operated upon any two elements of the set yes, the resulting element is again in the set yes, then we can say that the operation star is satisfied the closure property of the set yes. If it is so, the binary operation is binary on the set yes, then the set is closed under the operation star. If it is a binary operation on the set yes, star is closure property. Star satisfies the operation star satisfies the closure property. Closure property on the set yes. Closure property. Binary operation, algebraic structure, closure property. These three concepts we have seen. Closure means a set and an operation. After operating, the element is again a given set, means it is closed. The set is closed under the operation. Hence it is called closure property. And I have solved an example also in the previous video. That is example 12.1. There are some two problems in that example examining the closure property. Okay, now in this video I am going to continue few more properties of a binary operation. Now we are going to see few more properties of binary operation. That is, we are going to see in this video. If an operation is not closed with a given set, means it is not binary. And that structure is not a multiplex structure. Reversely, if an operation is not binary on a set, means the set and that operation is not a multiplex structure and it is not closed. Now we are going to see some more properties of binary operation. Binary operation. Some more properties of binary operation. Properties of binary operation. We can consider a particular binary operation. Some more properties of binary operation. We will consider an operation star again and an non-empty set yes, and we will see some more properties of a binary operation star. That is, other property is commutative property. Commutative property. This is actually second property. First property is closure property. First property is closure property. This is commutative property. Commutative property means any binary operation star, any binary operation star defined on a non-empty set yes. Any binary operations are defined on a non-empty set yes is said to satisfy commutative property. Is said to satisfy commutative property if A star B equal to B star A for all A comma B belongs to S, or for all A comma B belongs to a set S. A star B equal to B star A. A reversible operation is possible and or equal. That is called commutative property. For any two elements A comma B belongs to the non-empty set S and a binary operation defined on the set S, then A star B equal to B cross A implies that the set satisfies commutative property under the operation star. Third one, associative property. Next one is associative property. Associative property. Any binary operation star defined on a non-empty set yes if is said to satisfy associative property said to satisfy associative property if A star B star C equal to A star B star C. A star B star C equal to A star B star C for all A comma B comma C. Element C belongs to the set S. A comma B comma C belongs to the set S. Associative property. Any binary operation star defined on a non-empty set S is said to satisfy associative property if S star B star C equal to S star B star. We can associate it like that for any three elements on the set S. This is called associative property. And fourth one, existence of identity property. Existence of identity property. Existence of identity property. Here also, in a binary operation star defined on an empty set S is said to satisfy the identity property. Said to satisfy identity property. Identity property for every A. For every A belongs to the set S, there exists an element E belongs to the S, such that I already told you this is for every A and this there exists such that A star E equal to E star A equal to the element A. Then E is said to be identity element in A. There exists element E in S such that S star equal to E star equal to A, then E is called, E is the identity element in S. This is the identity property, existence of identity property. Any binary operation star defined on a non-empty set S is said to satisfy identity property for all A belongs to S. There exists an element E belongs to S such that S star E equal to E star A. If you operate any element in the set S with an element E, it's again the same element. That's why this E is called identity element in the set S. Next, finally, fifth property, existence of inverse property. Existence of inverse. Existence of inverse property. Any binary, these three sentences are same. Any binary operation star defined on a non-empty set S is said to satisfy inverse property. Inverse property for every A belongs to S. There exists an element B belongs to S such that S star B equal to B star A. S star B equal to B star A equal to identity E. E is the identity element in the set E. E is the identity element in the set S. S star B equal to B star A equal to the identity element. If we operate an element with some other elements, if you get an identity element, then that element B is the inverse element of A. This is the inverse existence of inverse property. The inverse property means for every A belongs to S, there exists an element B belongs to S such that A star B equal to B star A equal to E. Then B is called inverse element of A. Then B is the inverse element of A. That is B equal to A inverse. We can write it as B equal to A inverse. That element B is called inverse element of A, and it is denoted by A inverse. This is the existence of identity property, inverse property. Inverse exists only when identity exists. If a set with the binary operation does not have an identity element, means there is no necessary to proceed further for existence of inverse. Existence of identity leads to the existence of inverse. If the fourth property, existence of identity is fails, then we need not to find out the inverse, because identity is not in a set means there is no certainly inverse also. Now B is the inverse element of the set, yes, the element is. So for every element in the set, there is an corresponding inverse for that element. For every element, there is an inverse element. But identity element is only one element throughout the set. Identity element is unique in the set. But inverse element is, for every element, we have an inverse. These are some more properties of a binary operation with a given set. See, here B is the inverse element of A. A inverse is the inverse element of A. It is treated as A inverse. A inverse does not mean that 1 by A. A inverse means you cannot write it as 1 by A. It is not 1 by A. It is an inverse. You have to read it as A inverse is the inverse element of A. It means it is not 1 by A. You remember? It is not 1 by A. So these are the properties we have seen so far, and we will stop here and we will continue in the further concepts in the next video. Thank you.